Okay, we're going to cover data types. This is what we did in the second class. Only instead of taking 2 hours to do it, we're going to do it in about 10 minutes, which means we're really only going to give a cursory overview just so that you know. And that's not so bad because when you program, you'll start getting more of this information. So this is more just to make you familiar with a lot of the terms you're going to see and that we're going to talk about. So let's get started. So this is really just going to be all slides today for this lesson. So there are 4 basic data types. There's Boolean, which holds a true or false value. That's bool, B-O-O-L. There are characters. That's char, holds a single character. The letter A, for example. There are integers, which just like in math hold integers. There's various types of these of varying sizes. There is a short, there's int and long int, and long int, and these can vary by the operating system and the machine. Probably for most of what you'll be doing, a short int's going to be 16 bits, an int is going to be 32 bits long, or 4 bytes, so 2 bytes, 4 bytes, these are usually the same, 4 bytes, and then 64 bits or 8 bytes, and we'll have a separate advanced little seminar on bits and bytes. And then there's a type called floating point, which can have a decimal component, so 36.5 or 3.1415. And there's really two basic types of this: a float, which is 4 digits long and has, I think, about 5 digits of precision after the decimal point, and goes up to something like 10 to the 37th, and then double, which is 8 bytes and has probably closer to 9 digits after the decimal point and a lot more exponents. Okay, so there are also user types, and there are enumerations, and we'll talk a little bit about this later. There's also no type. There's something called void. So when you write a function that doesn't return anything, you can say void. And C has a long history of void pointers, and they probably get used some in C++. I don't really ever use them. You just don't need to anymore. Okay, using the basic types, you can construct other types. We're going to have to get into all this in other lessons once we're more familiar with programming, but there are pointer types where you take the basic type and put an asterisk after it, so then you've got a pointer to an int. Array types, which are just collections of a particular type that you can give a single name, but you could have basically a char array, could be a string. My name is Todd. And then I could get to each character individually by indexing by its position, 0, 1, 2, 3. Reference types, which is another advanced topic we'll talk about, and then what object-oriented programming is all about, structures and classes. So we're not going to get into any of that today. Okay, this was the homework, if I leave it up for a second, but it's kind of irrelevant for the purposes of this. Then there are some basic modifiers. Again, const means it's not changeable. Volatile is sometimes misunderstood. In embedded programming, it's really important. When you're reading in from a piece of hardware, volatile tells the compiler, hey, don't optimize this away. If I do the same read multiple times in a row or the same write multiple times in a row, it's really what I want to do. I want you to write it each time. And then there's some other things about where variables are stored, and we haven't really talked enough about all that. One of the easier ones to talk about is signed and unsigned. So for an integer, you can have a signed integer, so it'll start at 0 and go up to some large value. I'm sorry, just the opposite. Signed will go from a negative, typically equal or off by 1, negative 32,767 to plus 32,767 or 766. And then unsigned would go from 0 up to, say, 65,000. All that depends on the bits and the bytes, which will be the other seminar. So how many types are there really when you combine all these things? And so you can have, just for int, you can have an int, an unsigned int, a constant int, meaning once it's defined it can't be changed, a constant unsigned int, so this one is signed by default, a volatile int, a volatile unsigned int. So this adds up, so there's really a lot of types altogether, but there are really those 4 basic types. And then you can assign literal values in a variety of ways. So int I equals 10 assigns a 10 to I. There are some special characters that make your intent more clear and sometimes can work around problems. A capital L says this is 10, but I want to treat it as a 64-bit integer. This one is something more or less to watch out for. You don't know probably enough about alternate numbering types yet, but this is an octal constant, meaning base 8. This is not the same as 10 decimal. This really represents, if you in decimal, this represents the number 8, and it happens because it has a leading 0. So just be careful. All you need to remember is don't put leading zeros before your constants. And then this is hexadecimal. Now you won't do this by accident, but when you put a 0 and an X, that means, hey, this is a hexadecimal. So A is hexadecimal for decimal 10. So this is the same as 10. This is 8. This is 10. That's 10. Okay. So this is just saying that if you tried to compare I and J, this would be 8, this would be 10. It would not compare. They would not be equal. And then we talked a little bit in the first lesson about literal characters, but so when a car you specify with single quotes, and PowerPoint's turning them into these fancier curly quotes, but they're just the standard single quote character that you find below the double quote character. And we talked about new line, which you use a slash, a backslash, and then an N represents a new line. There's also a type called string, and we'll get into that later, but you can put a whole string inside double quotes. And C++ strings are kind of smart. They know their length, and they can do more things than, if you know C, than old C strings. And then finally, just some other useful backslash codes. So that's a new line, that's a carriage return, the R, that's a tab. If you actually want to embed a double quote inside a quoted string, you could use a slash double quote. If you wanted to enclose a single quote, if you actually wanted a slash character, you use slash slash. And then sometimes when you're dealing with binary data, you'll see this. This is slash X and then a hex, typically a 2-digit number, because, well, they can be more, I guess, but the actual hexadecimal value that you want to use. Okay, so for floating points, if you just specify 3 point with no letter, or 3.0 with no letter, by default that's a double. Now the compiler will cast that down and make it and put it in a float, so it will work. But if you want to be explicit about it, you should put the F after the number. And things like lint will give you warnings if you don't put it. Some compilers may not do it for you. So pi 3.14 F, because it's a float. Well, now we're at a double, so we can specify more digits, and we don't need to put any character by default. That's a double. Floats and doubles also support scientific notation, so you can use an E and -2. So this ends up being 3.14 because it's times 10 to the -2. So these are all valid forms of specifying a double. 1.23, you don't need the leading 0, you can just say 0.23, and you should avoid leading zeros. But in the case of a double, it works because there is no such thing as an octal double constant. 1.0, 1 point works, 1.2 e to the 10th. No spaces in here. All right. And then enumerations, we'll have to get more into this. This takes a while to get too in depth, and I want to finish this up in under 10 minutes. So, but the way you do it, you have enum, and then you say the name of the enum, color, and then the values. And then this would be 0, this would be 1, this would be 2. You can specify different numbers for these. A lot of times you'll see prefixes to the names, because these names get used just as they are, red, green, blue. Well, those aren't very unique, so sometimes you have name clashes, so people will do prefixes for underscore, and then I have a preferred way of, I like to put my enums in a namespace, and then I specify them with a namespace color, : red, like that. Finally, an admonition to not use magic numbers in your code. Don't put in 12, don't put in 10. You can create named constants, and we'll talk about how to do that. Constant forever equals 1, while forever. So even though you don't know what a while statement does, you probably can get the idea that I'm going to be in there for a while. I'm going to be in there for forever. I'm never going to exit that loop, as opposed to while 1. You'll see this a lot in code. It's not terrible. It's just, if you can, you always want to, it makes your code more self-documenting to use named constants instead of magic numbers. And also define 1 variable per line. You can do this. It's legal. Prefer to do it this way. And one of the reasons is you don't know much about pointers yet, but you would think, okay, this is 3 pointers to int. Well, it's not. What it is I is a pointer to int, j is a normal int, and k is a normal int. And that's very confusing. If you do it this way, it's not nearly as confusing. Okay, so that's it for data types.